Hello, everyone. The next session is starting now. You'll find it live on the TV screen. I've posted a link, and it's on the Racket YouTube channel. So go over there, and we'll get started with the last session of the day. Okay, we're now live with the last session of RacketCon, and we're going to continue the Rhombus portion by going on to have Matthew give us a walkthrough and tour and discussion of the actual experimental prototype that he's built on top of the Shrubbery reader syntax that we talked about last time. As before, Matthew invites you to make comments as you go. In the Google Doc, I'm going to have two regions, one for questions that you intend to be asked at the end and one for questions that you want to be asked in the middle. And you can also ask questions either in YouTube or in the Gather, and I'll notice those. And then after this, we'll move to the Gather for a discussion about Rhombus and all Rhombus related topics. So let's get started, Matthew. Take it away.
All right, thank you. So yeah, this is, well, maybe on this slide, this is both an example of how that Shrubbery syntax is supposed to work, and also a collection of ideas drawn from the wish list on the Rhombus brainstorming GitHub repo. So obviously we're going to have expressions in this language that are operators that involve some amount of precedence and associativity. So we could probably all guess and agree what this means here. But precedence doesn't have to be like absolute precedence, where each operator gets a certain precedence level. It can be declared relatively, and in the current prototype, there is no relative precedence between the not operator and the double equal operator. So this is just a syntax error. It's not a Shrubbery error, but it's a syntax error at the level of the Rhombus parser. Similarly, 1 less than 2 less than 3 is currently a syntax error. And also this one is 1 times 2 divided by 3 times 4. There's always a question of whether this times is in the denominator part or not. And right now you can specify precedence. That also depends on whether you're to the left or right of something. So this is ruled out as a syntax error. So this kind of relative precedence turns out to work just fine with the Pratt-style precedence parser that John Rafkin worked out for enforestation. So we take advantage of that. Function calls look like function calls. And array references and map references, they look like map and array references using square brackets. For some simple forms of data, we've got lists that are written in square brackets. All of these positions between the commas that are expression positions, so we could put 4 plus 0, and that would be the same as 4. This isn't quoted in the list per Racket sense. We have maps, where we have key, colon, value, and sets. Maps and sets are not worked out in great detail yet. That's really coming in future work, but we've at least imagined that the syntax would be reserved like this. If you want to define pi to be 3.14, you would do it like this. The val form is defining a variable like pi, and then the colon separates the name from the value expression. Here is a function using the fun keyword. So it's the area function that takes a radius, multiplies pi times the radius times the radius. Here is the definition of a diamond operator, which in this case is a less than or greater than operator. So it's operator, and then it's defining diamond here because it's in between two variables in the parentheses. It turns out you could just use def for all of these. It's not clear that this is a good idea, but this def is kind of like define in Racket, where it figures out whether you're defining a function or not, or in this case, operators or not, or even macros or not. This also opens up some ambiguity, so it's not clear that def is a good idea, but it's there now. In any case, in general, we have definition forms follow this kind of pattern. The definition form name, something about the binding, like the variable or a function prototype, colon, and then the body or the right-hand side or whatever it is you're defining it to. Branching forms, like if, use the vertical bar notation, the alternatives notation. So here we have if, an expression, and then a then branch and an else branch. So it's tacos on Tuesday and ramen all the other days. Here is a conditional form. So in the case of conditionals, again, we're using alternatives, but we have the predicate expression followed by a block, which has the body for that clause. So again, each clause is a vertical bar, and the test part is separated from the body by a colon. Really, it's the test followed by a block that contains the body. You may notice also that it's using else as a keyword, not as a binding. In general, we try to use keywords in this prototype wherever we mean some sort of literal. Here's match, looks kind of similar, except for match, we have an expression before the alternatives. And then these are, I've written literal strings here, but those are more generally patterns in the case of match. So overall then, for branching forms, we have the branching form name, maybe some sort of input, like in the case of match. And then if you need a label or a predicate expression or something like that, you put it as an extra layer of block between the bar and the body. Note that this means you can put definitions in if branches. You don't have to switch to con and so on, because the bodies are always in blocks. Let's see, I see there was a question about why I'm not so happy necessarily with def. I mean, I like def, but it's going to turn out that when you have bindings there, we can have patterns. And so what if diamond is actually a pattern operator here? So that's why def may not be a good idea, and it might be better to use explicit val and fun and so on. Let's see what else we have. So we can combine this definition and branching idea. So here is Fibonacci defined in a kind of pattern matching ML style, where fib of 0 is 1, fib of 1 is 1, and fib of n as we make recursive call to fibs. So fun recognizes alternatives and kind of splices together, in this case, a kind of match, but also this is how we would do variable arity functions. So here is a hello that takes either a name or a first name and last name and puts them together. This is a fun without a name. So this is kind of JavaScript style. This is a fun means lambda here. So this is a function, anonymous function that takes an argument and adds 1 to it. As we saw when we were talking about shrubbery notation, you can put functions conveniently enough as arguments here. If we wanted to find area using this anonymous function notation, like you might use explicit lambda in Racket, that works just like you would expect it to. I put it all on one line here, although every time I look at the slide, I think it would be prettier to put fun on the next line. So up to you. And here's the Fibonacci using fun with different cases. Okay. So now we get to the pattern match form. So wherever we have a binding position, whether for val or the arguments or a function, or whatever the pattern forms in match, these are extensible pattern matching positions. So I can use list notation right after the word val. And of course, that means match a list, where we have we must have 3 arguments for this to match. And A is the 3 elements of the list, I should say. A is the first element, B is the second element, and C is the third element. So if I do that and then check B, then B will be equal to 2. I don't think that's particularly surprising, and it plays out the way you would expect if we want to define function sum over a list of numbers. Then we have the empty list case and we have the non-empty case. Dot, dot, dot does what you would expect after this ns comma. As a list pattern, that means we have at least one item here and then any number of items after that. So if I call sum on 1, 2, 3, I do get 6. Now, the fact that binding positions are pattern matching everywhere, it's just, that's not the full extent, right? There can be other kinds of operators in binding positions that do different things. The double colon operator modifies a binding name to give it an annotation, a contract-like thing, in this case, string. So here what this means is if I put a pattern in hello as the argument, then every time I call the function, the pattern would have to match. In this case, since I put this annotation string on name, every time I call hello, it'll check that the 5 matches. Picking up another question I saw in the chat, there was, is the match form, are the match forms as rich as the match in Racket? Not yet, but this is extensible and we can add it. There is a question of how to get the same sort of optimizations out of this sort of general binding position extensibility mixed with different kinds of binding forms. But so the answer there is no, but maybe yes one day. Now we're moving towards macros. So we've got syntax objects. We use quote instead of back quote, or instead of hash quote, or instead of hash back quote. You should read this like you would read quote syntax, or really it's going to turn out to be quasi-quote syntax. So quote 1 is the syntax object that has the shrubbery 1 in it. And again, I say shrubbery, right? We're quoting shrubberies. They're not expressions or any other kind of thing yet until we parse them later. Right? So here I'm quoting the shrubbery hello, the shrubbery parentheses 1 plus 2, and so on. So quote's going to take just the next thing after it. So we can do symbols or numbers, but for bigger things, the only kind of thing we can quote, we'll need to have brackets around it. Here is a quoted expression for function. I misspoke. This is not an expression yet, of course. This is a shrubbery that happens to look like an expression for a function. Maybe it'll turn out to be used that way. For unquote instead of comma, which obviously we're using for function calls, we'll use the $sign instead. So if you read this as back quote and comma, it does exactly what you think. It makes the syntax object that has the shrubbery 1 plus, and then 3 times 3 gets multiplied by 4 to get a 7. So this really is an expression since we've escaped with the $sign. The quote operator and the $sign operators, these work in binding patterns too. So we're trying to unify syntax parse and match here while having them work all over the place. So here, I am matching the syntax object that has anything plus anything else. So this matches 1 plus 2. And of course, if I look at A, it's the syntax object 1. And if I look at B, it's the syntax object 2. Here I am using pattern matching to get an A and a B. And then I'm using quote as, this is of course really a template to put together the A and B with minus instead of plus. Dot, 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 again, does what you expect. So here, this is any number of things in parentheses. Right? So it matches 1 plus 2, where we don't try to make syntax lists. This is a simplification compared to S expression syntax objects. When you use dot, 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 you get a plain list of S expressions. Here I've got a comma in my pattern. And so this means A as a group repeated any number of times. So I can have any number of groups. I have 3 groups here, 1, 2, and 3. So A is the list with the syntax object 1, the syntax object 2, and the syntax object parenthesis 3 plus 4. Now I put parentheses around the 3 plus 4 here because if I left them out, it wouldn't match. I have just a single thing, A, in this comma. So that means a group with just one item in it. If I want to match any number of groups with any number of things in each group, then it's just another layer of dot, dot, dots, right? So $A dot, 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 comma, repeated any number of times, means I can have any number of pieces in each of these groups. So now A is the list containing the list of the syntax object 1, the list with the syntax object 2, and a list with these 3 syntax objects in it.
Matthew,
Yeah.
question about the whole thing about not having syntax lists. So one of the goals of syntax objects, among many, many other things, is to have really precise source location information that gets carried throughout the whole program.
Yeah.
So if we look at the right-hand side of that example, and you look at the parenthesis to the left of the 1, that one right there, yep, that parenthesis, that like goes, that is the parenthesis that would, that Racket would say is the source location on the syntax list.
Right.
How do I figure out to like highlight that as an error message in an error
Let's look at this at the shrubbery level.
Yep.
Right. So I've gone back to hashtag shrubbery, and what you see is this parses as the quote operator and then parens group 1, group 2, group 3. So it turns out that it's the parens right here that get the source location at the shrubbery level. So we are kind of losing that information here when we use dot, 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 because you don't see the parens, right? It's deconstructing it into a list. But this is a kind of interplay that happens with S expression dot, dot, dots also, right? You kind of lose the identity of the parens when you use dot, dot, dot there.
And that's why, for instance, you often see people binding the outer thing and then decomposing the inner thing so they can hold on to the outer thing's source location.
Exactly, yeah. And so the source information is there. It's just attached at a different place at the S expression level. Maybe that's less relevant, and what was really relevant here was about the dot, dot, dots, that it's kind of the same problem. And so, well, we'll try this out, but I think the experience has been that using regular list here might be a good idea.
Yeah, so in normal Racket programming, the number of times you have to do syntax arrow list is very infuriating.
Yeah, yeah, exactly. We're trying to get rid of that, exactly.
Okay. Very good.
Well, here's what it looks like when you make a macro. So I wrote expr.rule here. That's the name of, you could read that like define syntax rule. You could actually write def here. This is one of the patterns that def recognizes. This is a plain pattern matching macro. So we are explicit about sort of, one of the differences between match and syntax parse is the implicit quotes and escapes are very different. So we're gonna, in this prototype, we've gone match style, which means we're explicit about the fact that we're matching on some sort of syntax object here. And we use $sign when we mean to escape to match something in this position here. But the thunk and in a sense, this colon here are literals, right? This thunk is literal in the sense that that is the name we're actually defining, just like in syntax rule, define syntax rule because it's at the front. And the colon really corresponds to a block, of course. So here I've got the thunk form takes any number of parts in one group to make a thunk. So I could use it this way. And here, of course, the oops is just to illustrate that I haven't actually called the function yet, but here's how I would call that function. And I don't think there's anything surprising there. Okay, so plain pattern template, things that look just like the pattern matching and template construction forms otherwise. Here is the definition of a postfix postfix exclamation mark, right? And again, expr rule figures out that that exclamation mark is the thing that's being defined because it sees there's an escape first and then an operator. So here I'm expanding an expression followed by exclamation mark to be a call to some factorial function. So we could define factorial separately, of course. But then if I do that, then 10 factorial plus 1 gives us 10 factorial plus 1. So you can keep doing that for prefix and infix operators. those were expressions. That's why it was expression.roll. But we have now all these different positions that are macro extensible. And when I say all these different, well, we have expression positions, you're used to that. And you're used to definition positions. In this language, those are made much more explicit, like you define an expression macro or a definition context macro, and they're not implicitly one or the other. And then we can have bindings. We can extend the set of operators or forms that are useful in bindings. So here I'm defining the euro symbol to be a shorthand for constraining some pattern to be matched against a number. Right. So salary as 100 euros is fine. Cost as the string a lot. That's going to be a runtime error because when it tries to match a lot against a number, that will fail.
Can I ask a question about that example about the binding?
Yeah.
What if I do something weird, like I try to say that it's euro salary : string? If there's like multiple bindings, like I anticipate that this is going to be a problem. My question is, what kind of error is it? Is it an error that left-hand side is like not a binding place, or that nothing can pass these two tests?
So it's, are you changing the pattern here or the template?
I'm talking about the inval, like in the use and salary.
The use and salary. Okay. And if you do what? If you do salary : number. Oh, I see. You're allowed to do that because you might further constrain salary to be like a positive number.
Yep.
So then it would just be, these things can nest in general.
Okay. And so what about what is making it valid to nest? So the bind rule for euro, it doesn't appear to be saying I'm letting it nest. It's just so happens that $n is like unconstrained. It's just plopping it into the left-hand side of
right.
the colon, and colon itself. That's the thing that is saying, well, this is also a binding position.
Right. So if this were an expression macro, you would expect to be able to use any expression in this position, right? The same as for bindings. You can use any binding in that position, even if that's another : or if it's a pattern match or whatever. And the expansion here, it's just putting another nested binding.
And so the number spot, though, that is an expression position. And so part of colon's
Oh, I see. Yeah, this is actually not an expression position. This is an annotation position. Yeah, the third thing.
The new thing. You haven't got to that yet. But
you could imagine operators that have expression positions. That would be fine.
Yeah. And so the idea then is that part of colon's interface is I say, this is my syntax. This spot is a binding position. This spot is an expression position. This spot is an annotation position. And this has to enter our vocabulary as Rhombus programmers.
Yes, we have these positions in a way that were only latent or rare in plain Racket code. They become much more prominent here.
Cool. Yeah, great. Thanks.
Here's a more complicated macro. And the point of this macro, you'll notice it doesn't say rule, it says .macro. So now we're in the world with compile time code, but we don't have to make this radical shift in how we write things down from define simple macro to syntax parse. We're still using these explicit quotes anyway. And so this works out hopefully the way you think it would, enum followed by a block with some number of things. And it expands out to, this is a, notice it's a definition macro. So definitions return not just one parenthesized thing, but a kind of block that's wrapped with parentheses. So this is really an open parenthesis, and then we're starting a block right away. And we have any number of things that work in a definition form, groups that work in a definition form. So I'm defining a sequence of identifiers here to specific numbers that I picked counting from 0. Right? And that's why B ends up 1 after I define this enumeration. So the point of this is to just show you how all the things you would expect to work, what they start to look like. I haven't really talked about modules at all, but so here's the quick intro to modules. Instead of require and provide, it's import and export, which is the word I always want to use anyway when I talk about things. So we can try that word. But the big difference is not just the keyword change, but the fact that when you import by default, the names are prefixed. So instead of dumping into the namespace as we do, and that causes various backward compatibility obstacles, the default with Rhombus is to use a prefix. And it just takes the module name, which is typically the last thing in the path here, and uses that as the prefix. Right, so you already know that Racket Math exports square and pi, and here's how we're using them. What if you want to change?
Racket.math.
What?
Why isn't it racket.math.square?
Why dot and why slash instead of dot?
No. What I mean
down here, why is it racket.math?
Like, because if I have racket/math and linear/math, they're both math.
That's right. And you would have a conflict in that case. You would need to resolve it with a modifier in the current implementation. So after the import, you can have a block of modifiers. Here's some example modifiers. Rename pi to the symbol pi. And here's another one, expose. Expose lets that identifier through without putting the prefix on it. So in this case, I can use pi directly because I exposed it, whereas square, I still have to use a prefix. There's another modifier that says use this prefix instead of the inferred one. And that's how you could resolve the having two things that would otherwise be math. So I think this is an area where there's probably lots more exploration to do, but I think the key idea here is drawing from the wish list and talking about how we deal with prefixes of some form instead of dumping into the namespace. Operators work the same as other identifiers. So here I've defined the less than / greater than operator, which I'll pronounce UFO, which does something. It doesn't really matter what it does, but I just export that operator and then I can import it into this other module. Here I'm showing the no prefix modifier that just sets the prefix. Maybe expose all would be a better modifier name there. But then I can just use the operator directly. And this is probably one of the main reasons to skip a prefix, is to make using an operator convenient. That doesn't mean an operator is inaccessible if it does have a prefix. Like if I just import UFO and I don't want to dump into the namespace, I can still access that operator using UFO dot and then put the operator in parentheses. This dot is going to turn out to be different than the dot that we talk about for the rest of the time. It's kind of overloaded, but this is a sort of namespace path dot. That can be, normally you have an identifier, but if you have an operator, that's how you'd refer to the operator. So let's talk about the other dot, which brings us to classes. You could read this as struct as you want, and that was the keyword for a long time. But this is the usual posin struct or class that has an X and a Y field. That binds posin as a constructor in the way that you would expect. And now it might not be obvious how we're going to access, although clearly you would want this to work, and it does. So the dot operator here, this is just a regular operator in the sense of plus and times, but what it's bound to is to look for an X in its left-hand side. And for this posin, we will find an X. If we look for X, we'll find a 1, and if we look for Y, we will find a 2. Now posin, class posin really just finds posin, but inside of posin, you could reach other things. So if you wanted to get the function that selects an X out of a posin, you could, of course, write a lambda using fun, but posin.x more specifically is the one that works on posin instances, not just anything that has an X. So again, posin is bound. It's one name that can be used in multiple contexts instead of binding a bunch of different names like posin-x. So if I have this posin p, I could use posin.x to get the X successor that's specific to posins and use that to look up p, the X field in p. So different ways of writing the same thing, although it's not quite the same thing, of course. You can say either of the things that you might want to say. Here's how we'd write the classic flip example that flips the X and Y pieces of a posin. This is one way to do it. Right? I take P, I extract out the Y, I extract out the X, put them back together in a new posin. We could also write this using the dot notation, P.Y and P.X. I could also specifically constrain P to be a posin. So before, this would actually take any sort of thing that happens to have a Y and any sort of thing that happens to have an X and pull the pieces out and put them together in a posin. Whereas this is more like where I started, where I actually have to pass a posin in, right? Because that's what this colon operator does. And obviously, class binds the name posin so that it works in an annotation position as well. We could write it using pattern matching. So class also binds posin so that it can be used as a pattern operator or a binding operator. So we're going to get the X and Y bound here as long as the argument turns out to be a posin, and then we can just put them back together. So there's some things that I've written that looked similar but meant subtly different things, right? This took a P and looked for Y in there no matter what kind of thing it was. And that means that there's some sort of dynamic search going on to find a Y. Whereas when I wrote posin.yp, posin.y more statically refers to specifically the Y accessor for posins. So from the perspective of what thing do we pull out of P, it's at a known offset, say. It's static in that sense, or in the sense that it really has to be a posin and not just anything with a Y. It turns out that this is static resolution in the same way and at the implementation level too. So not only when you use this dot operator or colon operator, does it imply a runtime check, but it also propagates the information that P is a posin, so that this P.y really means the same thing as posin.yp and not the same thing as the P.y over here, where P can be just anything. So that double colon there, it's doing two things. It's a dynamic check to make sure it's a posin, but also it's associating some static information with P. So every use we know that is specifically a posin. Now this is starting to look like gradual typing, and yes, indeed it is a form of gradual typing. Unfortunately, we know there's a lot of complications there. Fortunately, we have a lot of experience in the Racket community with dynamic typing and gradual typing and contracts and such. So based on some of that experience and the current experiment is that there's also a dash colon operator that only does the static half of what double colon does. It says P, assume it's a posin. For the purposes of P.y, I mean I'm getting the posin Y here, but don't necessarily check. In fact, don't check when flip is called that in fact this is a posin. The check will be delayed here. Now the Racket optimizer will turn out to generate basically the same code for all of these cases, but that's not true in some other things. I mean, this is where we know that trying to look at dynamic check operators as types can sometimes go wrong, right? Here was my sum function from before. This is a linear time algorithm. This is a quadratic algorithm, the way I've written it. I wanted to say, well, I got a list of numbers. So the first thing is a number and all the rest are numbers. But now I'm obligating every call of sum to check that in fact, every element of the list is a number, not just that it's a list. And that could be bad. We know that this is one of the potential pitfalls of blurring the line between how you might use something as a type and how you might think of it as a contract. But if you use a hyphen colon here, then we're back to the linear time world. That in this case, this is just a kind of comment because claiming that n is a number doesn't especially select plus or anything. So there's a spectrum here, and exactly how the spectrum plays out is going to be one of the things that we'll work on going forward. Just to give you some more sense of the depth here, if I had to write origin colon posin so that origin X meant select a posin, that would be really annoying because I just wrote that it's literally the posin 0, 0 here. So there's also some amount of inferred static information that we would like for this to feel like a sensible programming language. Right? But in the current implementation, even if you define flip this way, you could look at flip and look at the body and see that it produces a posin, but flips, the part before the colon doesn't say anything about posin as the result. So in this case, this dot X is going to be a dynamic lookup of X. On the other hand, if I use colon after the parentheses, fun recognizes specifically colon colon as a way of adding annotations to function results, then this turns back into a static resolution. So it seems kind of type-like, and the questions become, how far do you push this static information? Like if I bind P to the result of flip and don't specifically say it's a posin, well, we want that to resolve just the same as before because we want to be able to give names to expressions. So, there's a whole bunch of information about this in the proposal about how binding forms add downward information, like colon colon can add some downward information. Expression forms provide some information that could flow upward, like to an enclosing dot form. And val is a bit special in that it's the one place where we pull information from the right-hand side and push it downward on the left-hand side. And that's how val p colon posin 0 knows that it's a posin for further access of x and y. Since it's not a type system and since the rules can be complicated, what do you do when someone tries to access something wrong? Well, the rule in the current implementation is that you fall back to a dynamic search and error and never provide static errors. So you can get good things statically, knowing that X is there and where it will be, but you don't get the bad things unless you insist. So here, this is going to be a dynamic error, right? From the rule I just described. Even though I said P is a posin, I tried to get an oops. Well, there's not an oops in posin. Maybe there's a subclass of posin that has an oops. I don't know, but probably this is a mistake, right? So I can say use static dot here, which is a macro basically that expands to define dot in such a way that it's only happy if it can resolve it statically. So then this is an error. So it seems like it might make sense to opt in certain cases to say that, yeah, I care enough about this code that I'm going to reason through how information flows and make sure that I get certain static information in place.
I have a
sorry?
I have a question, Matthew.
Yeah.
So, when you were talking about shrubbery notation itself, we were walking through the general rules of the reader, and you were using explicit examples about how this syntax would tend to show up. And now we're talking about like the concrete prototype. Yeah. So this static information thing, is this static information only about colon, colon, and dot? Or is this like a new mechanism of static information that goes up and down and can be pulled in these directions that you just happen to be using for colon, colon, and dot? Or is it just actually only about colon, colon, and dot?
No, you're absolutely right. It's a general machinery for pushing static information around, and it's part of the binding macro protocol, but it can be part of other protocols as well. So we've moved past the whole thing here is a grab bag of things that are about Shrubbery and how Shrubbery is deployed, plus some other ideas. And exactly, some of the ideas here are meant to be more general as well.
Yeah. So in the audience, like, this isn't just saying, oh, look, dot is cool and here's how it works. This is the Rhombus macro system the Rhombus expander is providing this totally new feature that's being used in this novel way. And you can think of cool ways to use it too. Yeah,
I mean, it's not totally new in that Turnstile does this and Match does this to a certain extent, but it's taking on a more central role, certainly. Yeah, building on our experience, but taking on a more central role. I knew there was too many slides on this topic, but here's some more examples. So I'm just going to say these examples exist. Look, you can put annotations in classes and they do what you would want them to do. So that's not everything that's worked out, but it's getting pretty close. And here are some things that are on the frontier. I call this a log scale because the things near the beginning are much less work left to do, or sometimes easier than some of the things towards the end of this list. But that's an example of things that some people have started looking at this point, like comprehensive data structures is something we would have heard about had Jack been able to be here today. But some of these other things, some of them are still wide open. Some of them have dissertations attached to them and planned. I think you saw this link before to the Rhombus examples. You'll find it linked right off the Rhombus brainstorming repos README. And for what I talked about today, look for the Rhombus prototype, a link at that page. All right, that's it.
Very good, very good. Now, there are a few big questions that people have. So one is, and I feel like this was something that like you and I have known the whole time, but maybe wasn't super, super clear. Like when I was talking at the very beginning about my prototyping language and stuff, I was just sort of like making stuff up. But you actually, your implementation like completely works. Like all of these things that you've shown, I mean, you popped up Dr. Racket a little bit, but like all of these examples are real. Everything that you showed today actually runs, it really works. So like for that implementation, I mean, you gave us a list of the next steps, but like what in the stuff that you showed is like not ready yet. You know what I mean? Like it's hard, like you didn't say syntax highlighting in Dr. Racket. Does that mean it's perfect now? Or is it like 99% or 80%?
Yeah, error messages I think are like 80%. And maybe that's optimistic. So there's been specific effort on them. They're not uniformly awful. But you know, it's like it is. You use something, and for your 10th example, you think, oh, that's not a very good error message. Let's go fix that one day. And some of it's going to need better sort of infrastructure in the stack, right? Like there's pieces now where the reader remembers the original text and it can use that in printing out error messages. Is that done the right way? Does it do the right thing on boundaries? Especially, does it do the right thing when you have a macro that takes a piece from here and a piece from there and puts it together? It often does something good, but I think I'm sure it needs to be refined. So, and then there's the indenter in Dr. Racket is, I think, basically there, but the single line indenter, there's a pretty good test suite for making sure that it provides the right options, but the region indenter is not quite right yet. And armoring and de-armoring that I showed earlier, that's like last week, so I'm sure it's got a ways to go still.
Now, someone has the question, which is like, does this compile to Racket base? Does it compile to kernel? Did you have to like change anything in quote real Racket, like underneath the covers for this?
So far, yeah.
Give people a sense of what it was. What's that like?
Yeah, it's basic. Racket base is essentially what it compiles to. So it's not using everything in Racket base, or it's not using, I guess match is not in Racket base. It is using syntax parse, which is not in Racket base. Syntax parse is not exposed as much as maybe as it should be. I'm pretty sure that was on the list. We have not so far had to change the internals of Racket, but I think the one thing that will force some changes at some layer, not like the Shea scheme layer, but some intermediate libraries are when we refine the notion of character. We can't get away with a character as a Unicode code point and have port counting do that, because then when you drop emoji in the middle, it messes up your indentation if you count it wrong. So indentation sensitivity is forcing us to do some more Unicode stuff, and that may affect the drawing libraries or the editor libraries or things like that. But at the level of like the Shea scheme, the compiler stuff, I don't really anticipate anything.
Well, you did add the multiple binding spaces thing that people may not have.
That's a good point. That's a good point. So that was an expander thing, not so much the compiler, but it was a core thing added to the expander. And it's in 8.3, but I found some bugs. So, you know, it's new.
And that is essentially how Posin binds itself as a binding position and as a annotation position and as an expression.
That's right. This is yet another of the experiments inside the design of Rhombus. It's the rare case where that experiment sort of touched the underlying implementation.
And as far as I know, that feature is not actually even used in the rest of Racket.
Not so far, right?
But it could
maybe never, but it might be one day. Yeah.
Okay. So someone has the comment that when they see dot, they want the holy grail of IntelliSense, where I type a dot and it shows me what I can see.
Yeah.
Can you comment on this?
Yeah, me too. So that's going to be some work down the road that could be on the list of things. Okay. It's interesting because it involves expansion to get that information, but the static info is there. So maybe there's a path to getting reliable, and maybe the environment would reflect when it's guessing and when it actually knows. All sorts of possibilities there, but yeah, that's definitely not there yet.
Now, a comment about this repository that you pointed to, that's the Rhombus examples.
Yeah.
Is this supposed to be people writing down a program that they wish would work? Are they like experimenting with syntax? Or they're supposed to write real actual programs that
Yeah.
really work with your prototype?
Right, exactly. That's what Sam Phillips has been doing, is what happens when we translate this code into this notation? Does it run? He runs into things, and then I say, yeah, that should be different. Or he says, oh, this should really be this other way. And so, yeah, it's running code to really test out the prototype.
And the reason I mention this is because this, like, it's great that Sam is doing this, but this is an extremely scalable project.
Exactly.
If you're
Yes.
back listening, like, hey, that sounds really cool. Go do this immediately. Go
Yeah.
say, download the prototype, start, just start trying to use this. And your feedback is 100% wanted. Like, if you write a program and it's ugly, you tell Matthew, this program is ugly, and then we will learn from that.
You tell the Rhombus discussion list, but yes.
Sorry.
You tell everyone.
Hey, you tell everybody. Now, we're going to, so another question that people have is about like, what's the array access, like with multi-dimensional stuff? Have you done anything with that? Is there anything?
And I'd imagine the starting point was more Java style, where you add multiple sets of square brackets. But of course, that notation, it's all macros, so you can do whatever you want. It's the #ref is the form that you would bind to take over what square brackets do. So.
Cool. Now, as we transition over to the Rhombus discussion thing, I want you to comment a little bit about like, what is it that we're doing? You know what I mean? Like you've presented this like prototype. Like, is this what it has to be? And it's now just like we're just steamrolling ahead, checking off all the boxes. Like, what's kind of the status of this project? Can you just like say that explicitly?
Yeah. So no, it's not at all. Nothing is set in stone. The whole project is experiment, and we're still at the experimenting phase. I woke up yesterday morning reconsidering this whole shrubbery thing. Like, what if I could just get rid of this indentation stuff and really have delimiters again? Wouldn't that be nice? How would I do that? Oh yeah, that's why I ended up here. But maybe someone else will figure it out. So I would say we're open to changing everything at that level. On the other hand, we don't want to be stuck in this pattern. So I think we really should move out of like brainstorming mode and go with what we've got. Like a lot of the ideas and the data structures and so on, they could be adapted if we go back and say, you know what, this other surface syntax would be better after all. The reason it takes a while is because there's lots of moving pieces, but the moving pieces can be composed in different ways. So it's all still a big experiment on, can we do extensibility, language extensibility more and richer and improve our tool set for this. Brainstorming was supposed to take a certain amount of time, but the next phase is just trying it out and making it work. That's supposed to take years. So we're in the multi-year phase to get to something that we would call the actual language with whatever its name will be. And
from my perspective, I feel like in that experimental phase, there were lots of ideas, and we have like, even if the thing that we have right now is not the solution, I feel like we've learned a whole lot of things that we super did not know before. So as explicit examples for me, the way that this static information way of pushing information up and then pulling it down, like you did say, yeah, we've seen that before in turnstile, but you've worked out so many aspects of that that I feel like any future version is going to have that, because it's like we've learned a whole lot there. Yeah. Similarly, I feel like the particular ways in which the enforestation boundaries between the parser and the reader and the enforestation, like that, by having a concrete prototype, we know way more than we did say with the Honu prototypes.
Yeah, I mean that's a piece between the two things I talked about. That was some work itself to figure out what is the right way. And the answer turned out to be, really exactly like in the Rhombus paper, that figure, take it out. But it took a while to see how that fits into the whole thing and its slight relationship to binding spaces.
Yeah, cool. Well, thank you, Matthew. We are going to go now to the section area A in the
in the gather, which is the upper left-hand corner. And so if you want to dig deep and talk about Rhombus, then go over there. And if you don't want to talk about that, but you want to talk about other things, then, hang around other places. And remember that, Rhombus is evolving. You go to the Rhombus brainstorming GitHub, and there's discussions going on, there's issues, there's pull requests to comment on. And part of including this so much time on Rhombus in RacketCon is an explicit invitation to the entire Racket world. Come check this out. There's more stuff going on there, and we want your input.
Yes.
Cool. All right, so the live stream's turning off now. We'll head over there.